Okay, YouTube, in this video we're going to continue our discussion of the algebra of functions, in which we're going to focus on compositions of functions, or what happens when we compose a function within another function. So we saw in the last video we could add, subtract, multiply, and divide two functions, say f and g. In this video we can see that we can compose the function f with g and denote it by f of g is how we would read this. It looks like fog. But we say it's defined by this equation here. F of g of x is the same thing as f of g of x. So in other words, what we're doing is we're plugging g of x into the function f of x. And in other words, there we'd say, well, what we would need to do here is find what g of x is first and then take that answer and then go shove that into f of x and then see what we get as an output there. So we say the domain of the composite function f of g is the set of all x such that x is in the domain of g. So in other words, the x value can't not be in the domain of g. It has to be in the domain of g of x because g of x would have to be defined in order for us to plug it into f of x. But we also say all g of x values in the domain of f. Okay, so in other words, g of x is going to get this range of values here. There are going to be certain values in its range that might potentially not be able to be in the domain of f or as an input for f because it would be undefined, or the square root of a negative or something like that, not real. So what we're going to do is we're going to consider this diagram here. We say the composition of f with g, f of g, is illustrated in figure 2.53. So basically, step one, notice that it says we're going to input x into g. So when we look at f of g of x, the idea is that we're working from the inside out. And so we're going to put x into g here. And what we get is input x going into the rule g and spitting out some output g of x. What we're then doing is taking that and we're plugging it into the function for f. So we're taking the output g of x, sending it in line through this other machine, f of x, which under that rule f spits out f of g of x. Or in other words, the y value at that input value, which in this case the input value was g of x. And we just define this as f of g of x. So again, what I want to re-emphasize here is that this figure is meant to reinforce the fact that the inside function g in f of g of x is done first. So we'll just work inside out. So looking at some compositions before we tune out on this one, we'll flip over to my next canvas here. And it says given f of x is this 5x plus 6 and g of x is this 2x squared minus x minus 1. It says find each of the following. We want f of g, g of f, and then f of g of negative 1. So the first thing I want to do on each of these, just like we did in the last video when we were doing operations, is rewrite from this new notation that looks like fog x f of g of x to what it truly means, which is f of, and what we're doing is we're plugging g of x into f of x. So what we're going to do first is we're going to look at the rule for f of x. We're going to say, well, what we're plugging into is f. So its rule is 5 times blank plus 6, or 5 times the input plus 6. The only thing here is that we're plugging in g of x. So from here we could say, well, yeah, I know what g of x equals. G of x is actually equal to this 2x squared minus x minus 1. I'm going to need a little more room here. 2x squared minus x minus 1. And all of this is being taken and having 6 added to it. So what we get here is, first of all, we need to distribute our 5 throughout. But we get 10x squared minus 5x minus 5 plus 6. And then combining like terms here, we can get this final standard form equation, 10x squared minus 5x, and this would be just a plus 1, positive 1. So this would be our f of g of x here, and this is the function that we got when we put g of x into f of x. So one good thing to consider, I think, at this point is, would we get the same thing if we did g of f of x, if we were plugging f of x into g of x? And so just to make this a little bit easier to visualize, I'll rewrite this as what we're really saying here. We're saying g of f of x. And we're plugging f of x into g of x. And so this one's going to be a lot less interesting, or a lot more work, because what we're doing is we're plugging f of x into g of x, which has a rule that says 2 times my input squared minus my input minus 1. And we're plugging f of x into this. Now, thank goodness f of x is not that drastic of an expression here. We have 2 times. We're just going to substitute in our expressions for f of x now, which in each case are, let me switch colors here, 5x plus 6. And I noticed that I'm missing something here. This squared right there should be right there. So what's not fun about this is we have to simplify this. And so we end up with 2 times 5x plus 6 times 5x plus 6 minus a 5x plus 6 minus 1. So we're going to have to start with our multiplication here, and I'm going to start by multiplying the 5x plus 6 times itself. So we end up with 2 out front. We get 5x times 5x is 25x squared. We're going to get 5x times 6 twice, so 30x twice. We end up with 60x's in the middle, and we'd say plus 36. Now all of this, I noticed that I had a negative in front of my parentheses here, so we're going to distribute the negative throughout, and we'll just call this a positive, and this a negative, and this a negative. So we would get minus 5x's. Minus 6 minus 1 gives us negative 7 there. So the last thing we need to do to end up, simplifying this for once and all here, we'd say is 50x squared plus 120x plus 72 minus 5x minus 7. And then just combining like terms, we'd have 50x squared. Looks like total x's here about 115, or exactly 115. And then 72, take 7 off that, we get 65. So this would be our g of f of x. And what I want to point out is that we did not get the same thing. That is not to say that we will never get the same thing for f of g and g of f. Not today at least. But not for these two, okay? And it's not always true. So now f of g of negative 1. Now this one is by far my favorite out of all of these, because really what it's asking us to do is find f of g of negative 1. And so our rule of thumb was that we're going to work inside out. What we need to do is define g of negative 1 first. So g of negative 1, if we're putting negative 1 into this rule, we would get this, negative 1 here and a negative 1 here. Order of operations says we'd square our negative 1 first. So we have 2 times 1 minus a negative 1, which is plus a positive 1 minus 1. So we end up with 2 plus 1 minus 1, which gives us 3 minus 1, which gives us 2. So this 2, this is the very same 2 that is equal to g of negative 1. They are equal. So what this means is, once we've found the value for g of negative 1, what we're going to do is we're going to say, well, then this is the same thing as f of 2, because 2 is what g of negative 1 equals. So now what we're going to do is we're going to go plug this 2 into f, which our rule for f is 5 times our input plus 6, and our input this time is 2. So we end up with 10 plus 6, or 16. So in other words, we would say f of g of negative 1, which is the same as f of 2, ends up being a value of 16. Cheers.